and dear students. We are gathered here today at the PSG College of Technology for a very special occasion, a lecture that bridges tradition, technology, and transformation.
On behalf of PSG College of Technology and the PSG Tech Alumni Association, it is indeed an honor and privilege to welcome you all to the third Dr.P. Radhakrishnan Endowment Lecture on Advancements in Generative AI and its Applications for Mechanical and Digital Twins. Organized under the Department of Mechanical Engineering, PSG College of Technology, this lecture series commemorates the exemplary contributions of Dr. P. Radhakrishnan, a visionary leader in the field of engineering and technology.
May I now take the honor of inviting the dignitaries to kindly come forward and take their seats on the dais.
To formally commence today's proceedings, may I request everyone to kindly rise for the Tamil Thai Vartha rendered by Ms. Sanjana from B.Tech Textile Technology.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் மது சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறைநுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிளமை திறம் வியந்து செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
Thank you, Ms. Sanjana, for that dignified and melodious rendition. With this auspicious beginning, we now proceed with the rest of today's program. Every memorable event begins with words that set the tone. To formally open today's proceedings, I take the privilege of inviting Dr. M. Arasu, General Secretary of the PSG Tech Alumni Association, to deliver the welcome address.
Very good morning to everyone. It's given me immense pleasure and pride to warmly welcome each and every one of you to the third Dr. P. Radhakrishnan Endowment Lecture organized by the PhD Tech Alumni Association and the Department of Mechanical Engineering, PhD College of Technology. I am delighted to welcome Ms. S. Vidya, Vice President, PhD Tech Alumni Association, for presiding over this function. Welcome, Madam. It is my great pleasure to extend a warm welcome to today's guest speaker and chief guest, Mr. Sundar R. Nagalingam, Senior Director, AI Consulting Partnership, Nevada, India, Private Limited, Bangalore, and alumnus of 1995 BE Mechanical Engineering Sandwich, who will be delivering the third Professor P. Radhakrishnan Endowment Lecture on the theme of Advancements in Generative AI and its application for mechanical and digital twins. Welcome, sir. I also extend a very warm welcome to our honorary patron, Dr. R. Rudramurthy, Director, PhD Care, who will be sharing cherished memories and insight on the contribution of Dr. P. Radhakrishnan. A very special note on gratitude goes to Dr. Dr. Prasad Raju, former scientist, Department of Science and Technology, Government of India, who graciously instituted this endowment in honor of Dr. P. Radhakrishnan, former Principal of PhD College of Technology and PhD Polytechnic College. We sincerely thank Dr. Prasad Raju for joining today's program through online. Welcome you, sir. It is indeed a pleasure to welcome Dr. P. Giriraj, Principal, PhD Polytechnic College, along with the Vice President, Secretary, Treasurer, secretaries, and council member of the PhD Tech Alumni Association. A special word of welcome goes to all our former faculty members, deans, head of the departments, and faculty member who have joined us to witness this endowment lecture, both physical and online. I also take this opportunity to warmly welcome Dr. K. Kannan, Professor and Head, Department of Mechanical Engineering, along with the faculty team of Department of Mechanical Engineering, PhD College of Technology. Last but not least, I extend my heartfelt welcome to all the students and special unities of PhD College of Technology and PhD Polytechnic College. Once again, I welcome you all to this important occasion on the third Dr. P. Radhakrishnan Endowment lecture. Thank you.
Thank you, sir, for those warm words of welcome. We now request Ms. S. Vidya, Vice President, PSG Tech Alumni Association, to deliver the presidential address.
Good morning to all of you. Esteemed Chief Guest, Mr. Sundar R. Nagalingam, Senior Director, NVIDIA India, Dr. Rudramurthy, Director, PSG CARE, Dr. Kannan, Dr. Arasu, distinguished faculty members, dear students and guests. As Vice President of the PSG Tech Alumni Association, it is an honor for me to greet all of you and welcome you to the third edition of Dr. P. Radhakrishnan Endowment Lecture. All of us are living in very interesting times. I think for the past decade, we have been privileged to witness almost dizzying pace of growth in technology, particularly AI. Artificial intelligence has been such a transformative and disruptive technology. On the one hand, it is very exciting. It also brings with it some apprehension too. Like all great industrial revolutions, there are many who benefit from the revolution and also a few who get left behind. The important thing for us is to be very agile and adaptive. Only the individuals and companies who are adapting to the new technologies can thrive. I think 10 years back, when we first learned of how AI is going to revolutionize industries, we thought it will be in the distant future. It will all be very slow and steady. But the pace has been truly breathtaking. I remember the first time when we entered a query into generative AI like ChatGPT and got an answer, and it was quite amazing. It has been a great privilege to witness all these changes. At the same time, as I head the CSR department in Propel Industries, our industry, and it is imperative for us to also measure the social impact all this will have. It can be a great democratizing tool, but also it can mean that few small-scale industries and people less privileged will get left behind and the inequality can grow. But I think lectures such as these, where all of us are exposed to these new technologies, go a long way in making sure that such inequalities do not happen. And Coimbatore has always had a history of philanthropy, and it has a very good social conscience. I'm sure institutions and industries will all come together and make sure that artificial intelligence will bring about equitable growth for all of us. I was just researching about digital twins. It is a new concept for me. From what I understand, it is a virtual entity, a virtual replica of a physical entity. So anything like a tool or a machinery or even entire factories can have a digital replica, and we can run simulations to design, to improve, and optimize all the processes. This opens up a whole world of possibilities. And as a member of the industrial community in Coimbatore, I want to thank PSG institutions for giving us this opportunity to listen to industry leaders like Mr. Sundar Nagalingam. Thank you, sir, for being with us today. We are all looking forward to hear you speak. I would like to finish with positive words from Mr. Jensen Huang of NVIDIA. He says, yes, AI will result in a few job losses, but it will create new jobs and new opportunities, and the increase in productivity and efficiency will ultimately uplift society. Thank you.
Thank you, ma'am, for your inspiring words and for reinforcing the vision that guides the Alumni Association. Every institution is shaped by individuals who leave behind a lasting legacy of excellence. To reflect on the life and contributions of Dr. P. Radhakrishnan, in whose honor this lecture series is instituted, I have the privilege of inviting Dr. R. Rudramurthy, Director of PhD Care, to address us.
Good morning, members on the stage, off the stage, and student friends. I am very happy to take few minutes of your time and present the successful journey of Professor P. Radhakrishnan at PhD Tech. The endowment lecture is also a part of exercise for the young student friends to understand how you have to succeed in your professional career after completing your engineering. So that is the reason why this kind of endowment lectures are arranged. And Professor P. Radhakrishnan is very unique and hardworking and very successful professional career in the campus. And if you want to really define what it means success to a professional career for an engineer, how do you define success? Is it the money that you earn, or it can be extended to the society also? For any successful individual, if you really want to define, is it the wealth one creates for himself, or the degrees one acquires during his journey or travel, and the administrative position he reaches? Are they the measuring parameters for defining success? There is something beyond that. Otherwise, there are many people who qualify for these things. And the lesson that we have to take it up, the young students who take it up, is that how do you define that success and how you can rate an individual in an organization? I had the opportunity to work with Professor Radhakrishnan from 1980s. I joined in 1984 in PhD Tech as lecturer in mechanical department. At that time, he was the professor. And we had very useful interactions. And when he became principal, and he gave me many assignments to work on, one of the very interesting fact is that he not only works very hard and create wealth for the institution, not for himself, for the institution. So I would say that the success, the definition of success for an individual in an organization is how much wealth that you have created for the organization, in addition to doing your routine work. Everybody is doing that routine work. But beyond that, what you have contributed. So I had the opportunity to work with him, and he gave me the first assignment to write a proposal on establishing a science and technology park, an entrepreneurial innovation center, incubation center at PhD Tech. Along with that, he has written a proposal for setting up a TIFAC core center, which is considered to be, before that, even before that, when AI and other things are discussed, many times people think that what is the relevance of computer science in mechanical engineering. But he has a different idea. He used to argue with us, those who are going for the engineering drawing at the time, that you should convert that all into computer-based, CAD-based engineering drawing. And there was a long discussion, and finally we all agree with 50% manual, 50% computer-based software-based drawings. I think still mechanical department is following that. At the time, he established one of the best CAD/CAM center in the country. Not only in PhD Tech or in this region, in the country, I would say. His idea is there are two ways of looking at the computer science, introducing computer science into mechanical engineering. Many of the premier institutions, they used to tell that you write a code. Start from there, you write a code to solve a problem with the governing equations. But Radhakrishnan took in a different way. Industry people, it is very difficult. Academic people, it's okay for doing PhD and other thing, but industry people, it is very difficult. He said that when there is a software available, why should we trouble in writing a software, creating a software again? So he brought CAD/CAM to the campus. And many industry, I know the many industrial organizations came forward to use these facilities. So that gave him a next step of establishing a 3D printing center at PhD Tech. When many people are talking about in the Western countries about the 3D printing, he established one here with the support of the DST and the industry. Again, the industry is the beneficiary. And he always makes sure that whatever academic process that we do, it should be relevant to the industry. So only then it is worth doing. Otherwise, there is no point in just writing an examination like an arts and science. So that was his idea. And it has become very successful 3D printing center in PhD Tech, and which has helped many industrial organizations. Then he became the principal, and he always makes sure that everybody work very hard like him. And I have never seen a person who is dedicated so much to an organization. That is again, I would say, the success. It is beyond the duty call that an individual has to contribute in order to make yourself successful in an organization. So then, after retirement, he became Vice Chancellor in VIT, and again, after 5 years, he has come back to PhD. He took up the challenge of setting up a nanotechnology center. When others are talking about it, he established a nanotechnology center, which is under the PhD Institute of Advanced Studies. And I had the opportunity to work with him on that also, on that project through PhD STEP. And PhD Institute of Advanced Studies, when we started, then the management would like to invite him back into the campus and handed over the project to him. And he made sure that the PhD Institute of Advanced Studies is very useful for the younger generation and society. So he introduced the concept of study abroad programs, international study abroad program, where a part of the program will be studied here and the remaining will go to the respective countries in the world. So the international collaborations he brought. So like that I can list so many things. I can only say the last point is, again come back, how do you measure the success of an individual in an organization, which the youngsters have to understand and follow it up. It is not the position that you reach by way of doing routine work. How much wealth that you have created for the organization. That is very important. And this is not only useful to the organization, and it is useful to the industry and the society. So that way, Professor Radhakrishnan is very unique, and I'm sure that all his wealth that he has created for PhD Tech has been useful to the society in Coimbatore and all over India, and even now many of his students are all over the world. who has been appreciated for his hard work and loyalty to the organization. And we can go on telling about all these things, but the youngsters, I would only say that you have to listen to these kind of stories, and you become one like him, and you should try to work in an organization to make your career very successful and create wealth for the society. Thank you for the opportunity. Thank you.
Thank you, sir, for your valuable words of remembrance. At this juncture, it is my privilege to invite Dr. S. Udayakumar, Secretary of PSG Tech Alumni Association, to introduce our esteemed chief guest.
Good morning, luminaries on the dais and off the dais. It's my distinct pleasure and honor to introduce our chief guest, Mr. Sundar Ramalingam, who is the Senior Director, AI Consulting Partners at NVIDIA India Private Limited, Bangalore. An industry veteran with over 25 years of experience, he is responsible for NVIDIA's AI Consulting Partners program globally. Mr. Sundar holds a mechanical engineering degree from PSG College of Technology and a master's in business administration from Bharathidasan University. He has gained experience in several top industries such as Ashok Leyland, Tata Elxsi, and Hewlett Packard India Limited. Mr. Sundar manages a team spread across the globe in NVIDIA. He and his team have been working with consulting partners on building transformative AI practices. His role includes working with partner executive leaders to define business goals, understand workflows, and build platforms on modern AI techniques, which is currently heavily focused on generative and agentic AI. He is also responsible for establishing a joint go-to-market strategy by verticals and align the same to NVIDIA's regional business goals. He has exposure to work cultures of the US and the Asia Pacific regions. We are incredibly honored to have you with us, sir, and we express our sincere gratitude for your presence, sir.
Thank you, Dr. Udayakumar, for the warm welcome. Good morning, everyone. Professor Dr. Rudramurthy, Dr. Kannan, Ms. Vidya, Dr. Arasu, thank you for having me here. I have delivered, a lot of lectures in multiple forums, and one lecture which I really feel very honored and humbled is the one which I'm going to deliver now over the next 35 minutes or so, because I was sitting exactly in this position where all of you guys are sitting, and I don't know, I'm having goosebumps here because it's an honor for me, and thank you, Dr. Velavan, Dr. Kandaswamy, for being here, Dr. Chandramohan, Dr. Mohan Sundaram. They taught me engineering drawing and at that time. Dr. V. Ramachandran, we all love him a lot. He taught 2 papers in manufacturing processes. We have Dr. Girirajan, thank you, sir. Dr. Chandramohan, he taught me DFM and machine learning. And Dr. Jayachitra is our classmate, my classmate, very happy to tell all of you. So, it is like, sort of a surreal experience, honestly, for me to be here and to be talking to the people who I respect a lot, who made me what I am today. The seeds of what I am today was sown in this campus, not exactly in this hall, at the time this hall was not there, but it is where I grew up from being a boy to a man. So it's an extraordinary experience. I really want to recall a few professors. I have been blessed to learn under them. Of course, Dr. Radhakrishnan, and I used to spend a lot of time in the CAD/CAM center which he founded, and it is quite funny, you guys will laugh. We are not allowed to wear our slippers inside. So outside the CAD/CAM at the time, there are a lot of slippers, and we had to remove our slippers and go inside. Those are the days when we grew up. Dr. Tyagarajan, P.R. Tyagarajan, who taught us very, very tough subjects like fluid mechanics, fluid machinery and all. Toughest of, to me at least, that in mechanical engineering. Dr. Krishnamurthy, who taught mom for me, I mean, mechanics of machines couple of times for me. Still, I use mom and SOM. I mean, I don't use mechanics of machine. Dr. Vidya Sahar, Mr. Sivakumar, who taught us physics. Not sure if he's around still. Dr. Kandaswamy, senior Kandaswamy, we used to call him as, who taught us mathematics. I'm sure I'm missing few names, but it's an extraordinary set of teachers that I was blessed with, myself and Professor Jayatra, who is my classmate. I'm using is, not was. I mean, she continues to be my classmate. So we were all blessed with such extraordinary teachers, and it's an honor to be here. Sorry for the long preamble, but I thought my talk will have no meaning if I don't acknowledge my alma mater, which helped me to grow up. All right. Now, so lot of good things are happening in AI, to Ms. Vidya's thing. I mean, I really want to look at it as a positive thing. When Professor Kannan spoke to me, and I was asking, sir, what do you want to be the theme of the talk? And what he said is that there seems to be some disparity between what is happening in AI and what's happening in the mechanical engineering side. Maybe they are not connected. So if you're able to draw a parallel between the two and guide our students as to, hey, being mechanical engineering students, this could be a path for you to progress your career when it comes to AI. That could be a good topic, is what Professor Kannan guided me. So that is what I will try to establish. It's a very short time, what I have been given. I will try to do justice to it as much as possible. Let me try to, remove some myths about a lot of words that are constantly being used / misused in the industry today. I mean, before we could blink our eyes, we could even understand what is happening, AI has grown in leaps and bounds, right? I mean, it's a brutal technological growth is what we have witnessed over the past about 10 years or so. What started off as a rebirth of deep learning, which is an extension of machine learning and advanced data analytics, has now gone to generative AI. I mean, deep learning uses the technique called deep neural networks for understanding patterns and commonalities that are hidden inside data, right? You learn the patterns and the commonalities that are hidden inside the data, and using that learning, you try to predict outcomes when similar data is given to you. That is, and it uses a technique called as deep neural networks, DNNs. That is what deep learning used to do. And interestingly, deep learning is not new. You'll be surprised to know that it has been there for about 20, 30 years. Yeah, but it was always restricted to the research institutions of IITs and RECs and other institutions. It never came out of that. But then the advent of very, very strong computing technologies, thanks to the company which I am working in, NVIDIA, and the availability of data led to the rebirth of deep learning. And then came generative AI, where you generate content. It is just not question answering, and it's not mining intelligence. You generate content. How a human being generates a content, a painting or a music or a written summary of something, you generate content. And then we have now moved on to something called as agentic AI, which is an extension of generative AI, but which can do what is called as reasoning. I'll touch upon it a bit later. Just hold on to that topic for now, a bit later. And the logical extension of that is what we call as physical AI, right? Which is an amalgamation of the physical world and an intelligent virtual world, which is born through AI. So this is the logical evolution of AI. And the most interesting thing about this is that this has happened at breakneck speed within about 10 years or so. That's it, just about 10 years. So the backbone of generative AI or agentic AI is what we call as large language models. I'm sure your counterparts in computer science and engineering are studying this, but being mechanical engineering students, maybe you don't have exposure to this. I don't know, I'm not sure about it. But this is the fundamental building block of whatever is happening in the AI world today, right? And these are basically very complex mathematical models. People use multiple, fancy terms like, foundation models, small language models, etc. But it is nothing but an assembly of very complex mathematical models which can predict the outcome of an input. Okay? You provide an input. What is going to be the outcome of that input is predicted with the help of an extraordinarily complex mathematical model. And these are called large language models because they mimic the language which you and I use, right? Now, for these language models to be existent, for agentic AI and generative AI to be existent, there has to be three major requirements. Number one is accelerated computing. It needs brutal computational power, extraordinary computational power, and that is what is the contribution of my employer, NVIDIA, to this science, to this world, is that we provide the extraordinarily brutal computational power that is necessary for running very complex mathematical models and for handling huge amounts of data. And we need training and inferencing tools. And last but not the least, you need AI expertise. And that is where, guys and ladies, you can contribute. All you have to do is you have to ensure that you are able to create a parallel between mechanical engineering and the applications of mechanical engineering in AI. And that is what, I mean, I'm a mechanical engineering student as I was introduced by Dr. Uday Kumar. I did my BE Sandwich Mechanical Engineering, passed out in 95. So that is what I was able to do, I have been able to do, where you draw a parallel between what your fundamentals of engineering which you learn in the college and how it can be applied to this growing world of AI, right? So I know that I'm going a little fast, sorry, pardon with you for that, because I have limited time provided by Dr. Kannan. So I mean, I'm going a little fast, please bear with me, and if you have questions you can always ask me at the end of the session. So what is this agentic AI? Okay, it's very important for you guys to understand this. As I said earlier, generative AI generates content. Like you can give a prompt and you can tell that, hey, create a painting of something very fancy, let's say a blue frog wearing a red cap. You can give a prompt like that and you will get a painting or a picture of a blue frog wearing a red cap. You will get that, right? Or you can generate music, you can generate content, you can write technical content, you can read and understanding very domain-specific language used in, let us say, a law firm or a medical literature, etc. So all these are generating, right? So you ask for something and you get something back. That is generative AI. Agentic AI takes it to one step ahead, where it is just not generation or question answering, it is reasoning. It is contextualization of the information that you know, and also having a memory of what has happened before, right? And understanding the user's needs, contextualizing it, and giving you a plan. That is what is agentic AI, right? These are agents like human agents, these are electronic agents, which just don't answer your question. Give me a painting of a blue frog is a question, and the blue frog painting comes back is an answer. No, it doesn't stop there. But if you tell that, hey, if I were to reduce the premium that I am paying to the insurance company by 30%, okay, how will it impact my coverage and what are the network hospitals that will be impacted by it? A complex question like this. That means it is just not using the mathematical model. The model needs to go to a calculator, understand what 30% is. It needs to go to the internet and find out what are the network hospitals, right? So it needs to use a lot of tools and techniques which are just not mathematical models, sources of data which are available, and ensure that they are all made use of in giving you a plan, okay, in giving you a holistic response. That is what agentic AI is. Okay? It is an extraordinarily complex thing that human beings have achieved today. Okay? It needs, number one, contextual understanding. It needs combining multiple sources of data. I talked about it. It needs answer validation. You give an answer, it needs to be checked and validated against the principles of the organization, against the conformance standards of the company for which it is working. It needs to be a validated answer, right? I mean, for example, an insurance company cannot tell that, hey, I rejected your loan because the computer rejected it. Okay, it has to be explained. That is where the concepts of responsibility, explainability, and all come into play. Where it is just like a human being applies his brain and works with multiple sources of information and data to arrive at decisions, to arrive at plans, to arrive at a project. That is what agentic AI does, right? Handling ambiguity. I mean, there are a lot of interesting examples that I can tell. For example, if I say that, hey, the policeman chased the thief, the policeman and the thief fought with one another. Luckily, he was shot. Okay, luckily he was shot. So who got shot here? The policeman and thief were fighting, and luckily he was shot. So who is he here? Who is he here? Thief, right? The terrorist, whoever, right? It's not the policeman. But why? I just said he. How are you able to relate that he is the terrorist and not the policeman? Because you have contextualized my question, and you know that since I used the term luckily, you identified as a terrorist, and had I told unluckily he got shot, you would have told that the police got shot. Imagine training a machine to do this. Right? That is what is contextualization. Right? It is extraordinarily difficult. Right? Dynamic adaptation. It needs to keep on updating to the modern worlds. Just like you are honing your brain to adapt to whatever is happening, to the latest things, to whatever is happening all around the globe, to the policies of the government, to the policies of your institution, PhD Tech, to what, I mean, there are like so many things which you unconsciously adapt yourselves to. Just imagine driving your car. You adapt to the entire environment around you, right? I mean, driving a car is not easy. I mean, the brain does wonders when you are driving a car, but we don't realize it. Imagine teaching a machine to do that. That's what is dynamic adaptation. So the sum total of all these extraordinarily complex tasks results in the birth of agents, right? So what does an agent do? What does an agent do is, the core of agent is a large language model, which is, as I said earlier, a very complex model which has been trained with very, very multivariate data, which makes the model intelligent, right? Now, it uses, the slide has used the term thinking. It actually, I mean, it doesn't think like you and I think, but then thinking and reasoning is what it does, right? It uses tools. It should use a calculator, it should use whatever tools that are available. It uses the memory from the previous learnings, whatever it had, and it is able to contextualize other agents, and it has to interact with the person with whom they are working with, right? So that is what enables it to become a holistic agent, right? A couple of quick examples. If you were to ask a question of what is NVIDIA, that is generative AI. It will go to the web using a technique called as RAG, which is retrieval augmented generation. It is going to find out what is NVIDIA is, and it will give you the answer that is given in the box. Imagine you're asking this question, right? I need to figure out how do I make a seating arrangement amongst 5 people, a family of 6. You just read the prompt there in the gray box, and it's a complex problem. Now, you need to extrapolate this not to people, how do I seat a mother-in-law and a daughter-in-law who fight with one another. That is the example that is given here because it's a very interesting example. But then imagine, lining up planes that need to land. I mean, the work of my ATC, if it needs to be automated, things like that. So creating a plan, a program is what agentic AI does, right? What it means is an increase in the knowledge that needs to go into creating the model, which means it involves a lot of intellectual work to be put by human beings, by like all of us. And that is where you have a huge opportunity. As Vidya said, I was quite impressed with the homework that she had done before she came here and gave her 3 minutes talk, is that AI is not going to replace you. AI is not going to replace you. But somebody who has learned to use AI the right way is going to replace you. Okay, I'll repeat it. AI is not going to replace you, but somebody who learned AI in the right way and who uses AI in the right way is going to replace you. Okay, you get the point, right? What I'm trying to say. So, I mean, do not ever think that, hey, I'm like mechanical. No, I'm a mechanical engineering student. I'm doing a lot of work in AI today, right? Not in programming side but in related works. So this is an enormous thing, and a parallel or a connection between mechanical and AI is what we call as digital twins. Okay, I'm going to talk a little bit about digital twins over the next few minutes or so, right? So, I mean, picking up on the topic on the previous slide, so specialized agents, they form teams to automate work, right? So there is a bug tracking agent, there is a tech documents agent, there's a coding agent, and then there is an orchestration agent. Imagine this to be the same the work done by human beings today. There's a bug tracking, I mean, there's a test engineer, there is a documentation engineer, there is a coding engineer, and there is a team leader who ensures that all three of them work in unison, right? And it is just not one, the previous slide, whatever you saw earlier, this slide tells you how an agent works. Now, it is just not one agent who is working. Agents work together in unison. Okay, guys, one more thing I wanted to be very clear. None of this is futuristic. None of this is a magical world which sounds science-fi movie, which may happen. No, it is happening today. It is happening today in the advanced technology world. And in another 5 years now, the life that we are going to live is going to be totally influenced by agents. The syllabus that will be taught in universities is going to change a lot. It's a sea change that we are undergoing. Okay, I really don't want to get into the topic of whether it is the right thing to do or wrong thing to do. I mean, I have my own reservations against it. I mean, I want my children, my grandchildren to have the jobs to do. I mean, it's not that everything cannot. I don't want a scenario when machines do everything. But putting that aside, all those philosophical things aside, let's talk about technology now, right? So there is a set of agents who work together, and and they form an agent. That's very simple to, I mean, if you look at how a college is run, multiple teachers report to the HOD, and multiple HODs work together when they form a curriculum. There is a dean of studies, there is an academic council, then there is a principal, then there is a management committee, and principals work together. And there are, Professor Rudramurthy explained to me the work that is done by CARE, which is multiple institutions are brought together in terms of designing curriculum. It is a complex, system where lot of human beings like you and I, Homo sapiens, interact with one another and make the entire system run in a seamless way, like a well-oiled machine. Now, that is what agents are getting created, where multiple agents run together, they are orchestrated by an agent, and they all deliver a system. It is just not one use case or one problem that gets solved. It's a system, like a college being an institution. It's a system that gets delivered there. Now, building this type of agentic systems is extraordinarily complex, right? I mean, there is architectural complexity, there is a repeatability. You cannot keep on writing it again and again, and there is a code reuse that needs to be done. It has to be performance oriented. Nobody wants to call a call center where you are getting answered by an AI agent and you cannot wait for 2 minutes, right? You don't want to do that. I mean, when you ask something, you need the answer. That is how it works. Learning and adaptation, we talked about it. Safety, security, and privacy, very, very important, because your data is getting used. I mean, you cannot just go anywhere and get misused. So building agentic systems is complex. So what is the message from this slide? When something is complex, who is going to solve it? Engineers are going to solve it, right? So if you guys understand where this complexity is and orient yourselves to learning, acquiring knowledge which can solve this complexity, that is going to open up a lot of opportunities for you. Okay? Please don't think that only Python programmers and C++ programmers and computer science engineers who understand DNNs, they only have jobs in AI. No, absolutely no. There are so many allied fields which are necessary, right? And that is what leads on to my next topic, which is, thank you. Leads on to my next topic, which is, I'm trying to connect the dots to mechanical engineering now, right? I mean, just as an example of, I mean, the epitome of, in my view, the epitome of mechanical engineering is automotive. I mean, of course, I think aerospace is even more complex, but then it's really automotive, right? So I just took one example as automotive to explain to you how that industry is getting shaped up by AI today, right? So we have this concept of SDVs. Have you heard that? Software-defined vehicles, right? The vehicle is defined by software. The ECUs, the electronic control units that drive the vehicle, they are all software-driven today, right? And enhancing the in-cabin user experience. When you sit inside a car, you are entering an AI world. It's like a virtual world, we are entering it. And those two boxes represent the car experience. But how about the support system for the car in terms of manufacturing, in terms of customer services, in terms of actual services, the factory level services that happen, designing, marketing, everything is now moving a lot towards AI. I'm sure you have learned this topic called the PLM, which is Product Lifecycle Management, which is a governing system for everything that is mechanical, specifically from a design perspective, right? I mean, so the PLM tools like Siemens, UGNX, Autodesk, etc., they are all adopting AI in a big way, right? In terms of creating intuitive designs, in terms of creating adaptive designs, etc., it's a lot of AI is getting employed today. Okay, and these are the top generative AI use cases and workloads that get into the area of into our area, which is the mechanical sciences area. When I say mechanical engineering, what I mean is mechanical sciences includes production and allied robotics, AI, etc. Mechanical. Let me try to use the term mechanical sciences, right? So I really don't want to read through it and bore you. I'm not here to read the slides, but then these are areas where you have a lot of opportunities as students of mechanical sciences, right? Creating chatbots and copilots, recommendation engines, vehicle data analytics, code generation for software-defined vehicles, in-vehicle experiences. I mean, very, very interesting field. And companies like Mercedes-Benz, Harman, etc., they are doing a lot of work in this area, specifically in European countries and in Japan, etc. These are big areas which are getting developed now. Driver personalization, computer vision based experiences, etc. Now, I mean, once again, a cockpit of the future, everything that happens inside the car and outside the car, using advanced computer vision techniques, okay? Like LLM, we talked about LLM right at the beginning of the talk, which is large language models. An extension of LLMs is VLMs, which is vision language models, right? And vision language models is the adaptation of LLM for computer vision, right? And VLMs are getting used in a big way for all the boxes that you are seeing on the screen, okay? I could go into each of the box and spend like, I don't know, maybe a minute into each one of it, but I'll probably skip it for now. But then, guys, please do understand that this is a fascinating field when it comes to applying AI to mechanical sciences. That is what is the parallel that I wanted to draw here. Now let's talk a little bit about digital twins, right? So digital twins is an extraordinarily interesting phenomenon, right? So what is a digital twin? Okay, a digital twin is an electronic replica of the actual physical thing, right? Like, I mean, the next question you should ask is, has it not been there for like decades now? We create CAD drawings. All the CAD drawings are digital replicas of physical drawing, physical parts, right? I mean, that is, it could be surface modeling, solid modeling, it could be simple two-dimensional drafting, but they are all electronic replicas of the physical thing. So why this fancy term called digital twin? So what makes a digital twin different from a CAD model is this. Number one, it looks real, right? It is held in a virtual environment, a parallel world, like we are now all looking at the physical world, a parallel world which is a virtual world where it looks very real. When I say it looks real, that is where this concept of what we call as physically based rendering comes into play. Okay, I repeat, physically based rendering. What is physically based rendering? You all know what is rendering, right? Rendering is, you render, if I take a picture of this and render it, that is rendering. You all know what rendering is. It looks real, right? Now imagine, now You all look to me like this because of that light and this light and light is behind it. The light sources define how you are looking at. If I change these lightings to a spotlight or a little light or moonlight or sunlight, I need to render you again in order to understand how you are looking like, right? But if I am creating a virtual world that needs to look the same, I cannot keep on rendering you again and again and again. The virtual world has to be intelligent to get updated as per the optical conditions, right? How do you make it intelligent? By giving the virtual objects have to be given physical properties, have to be given the optical properties. Okay, how much is the reflectivity of your surface? How much is the absorbed light gets absorbed? How much is the luminosity and things like that? So that when the lighting conditions change around you, your looks also change dynamically, dynamic adaptation. Okay, do I make sense? Or is it, do I make sense? Yeah, that is what I mean by virtual world. Okay, creating a virtual world where they look real, right? Now, most important is they just should not look real, they should also behave real. How do I make them behave real? If I have modeled this bottle, and if I keep on moving this bottle, the moment it goes here, it has to fall down. It cannot float in the air. Okay? How do I ensure that it falls down in the virtual world? By defining the gravitational motion, by defining the weight of this, or defining, and I have to give it the physical properties of this. So I create a virtual world where two things are achieved. Number one, they look real and they behave real, right? That is what is a digital twin. Okay, where you go to the digital twin and give any condition, any degrees of, any physical condition, it has to behave the way it behaves in the physical world. That is when the virtual world becomes artificially intelligent. That is what we call it as a physical AI, right? Now, digital twins is used in multiple ways. Layout and planning, because the factories of the future are going to be without human beings. That's it. Guys, mark my words, everything that moves is going to be autonomous in the days to come. Everything that moves is going to be autonomous. Be it a car or a machine or whatever it is, if something moves, it is going to be autonomous in the next few years' time. Right? Now, how do I train it? How do I make, I cannot keep on creating physical conditions and boundary conditions and degrees of freedom and write programs to ensure that the robotic arms moves this way, restrict the DOF to something. No, it's not possible. So programmable robots, those things are gone. So what is that we need to create? We need to create self-learning robots, where the robots learn from the boundary conditions, learn from the physical conditions, and adapt themselves to the needs of the physical world. Just like how a human being, a human worker, knows that he has to stretch his hand a little longer because the pot fell down, right? Falling down can happen anytime in the world. That learning has to go into a robo, and that is a big difference between a programmable robo and a self-learning robo. And the world is moving towards self-learning robo, and virtual worlds which look real and behave real, also called as digital twins, they are the methodology to arrive at self-learning robotics. Okay, I hope I was able to explain to you what exactly it means, and things like process simulation, remote monitoring, industrial inspection, robot fleet simulation. So that is a very, very, very interesting one. Robot fleet simulation. You see that how that robots are getting trained in the virtual world, because when they walk, they need to fall down when they need to fall down, or things like that need to happen, right? And they need to pick up, etc. Now, that is where this NVIDIA has something called as Omniverse, which helps you to create your own virtual worlds that look real and behave real. And that is the fundamental concept of digital twins, right? Now, this obviously needs extraordinary mechatronics knowledge, robotics knowledge, strength of materials knowledge, the ability to define physical properties, optical properties, the ability to prompt. There's something called prompt engineering that is coming in a big way, and that all will come from the mechanical sciences field only, right? Now, so much of rosy things, I thought the picture would be incomplete if I don't tell you the risks also that are involved. So generative AI comes with a lot of risks. Data privacy and security, IP rights and copyright, like a autonomous car goes and hits a person and he gets injured. So who is answerable to that? Is the car manufacturer or the chip manufacturer, or who? When a driver is driving, it's very easy. The driver is answerable, has to be held responsible if he hits another person. What if an autonomous vehicle hits a person? If one particular brand, so things like that. Biases, errors, and limitations, because everything is data dependent. Okay, data engineering is huge here, because keep in mind that these are just mathematical models. The mathematical models gain intelligence through training, which comes from data. Understanding patterns and commonalities in data is what is. So if the data is skewed, the intelligence is skewed, right? It's very simple. Okay, garbage in, garbage out. So ensuring that the data is sacred, is sacrosanct, it is right. Okay, it's clean. That itself is a big thing. Okay, forget AI, forget deep neural networks, forget agentic AI, forget generative AI, physical AI, all that is fine. Ensuring that the data that you create is created the right way and used the right way is a problem. That is a huge business opportunity by itself, and a lot of companies are working on it, thanks to these things, the downstream applications like generative AI and all, right? So all you have to do is you become a data expert, okay, and ensure that you prep the data the right way. That is a big job opportunity for all of you guys, right? That also is a ethical implementation, and of course malevolent activities can happen, right? If you have to, if somebody needs to kidnap a person, all he has to do is get into the car and reprogram the car, right? It sounds so simple. It's like bribing the driver and asking the driver to drive the person somewhere else. So how do I control that? That is where safety and security come into play. So the concept of cyber security, okay, has been redefined. What is cyber security, which we all know? Ensuring that no virus comes into my laptop. That is what has been cyber security so far. But that is very obsolete. It's invalid. Concept of cyber security has gone so much beyond, because the risks involved in malfunctioning of AI, in term either intentional or unintentional, if it malfunctions, it's going to be a catastrophic thing. So the concept of cyber security has changed upside down thanks to AI. Okay? Once again, guys, why am I telling all those things? Because these are all opportunities for you. You need to pick up where to ensure that your area of interest and develop your skill set around it, get yourself trained around it, and ensure that you ride the wave, and you ensure that somebody who understands AI better than you, uses AI better than you, does not replace you. Okay, once again, AI does not replace you. Only a person who knows AI better than you will replace you. Okay? All right. So there are multiple things. I invite all of you to go here, ai.nvidia.com. Very, very good resource. Extremely good amount of information you can learn. A lot of self-learning can happen. Go to ai.nvidia.com, and you should enroll yourselves into a developer program of AI that from NVIDIA, developer.nvidia.com. If you want to take picture, you can take picture of the QR code. But it's very simple. Developer.nvidia.com. There is a lot of good stuff. Most of them are free. Not all are free. Most of them are free. You don't have to pay anything. You just enroll yourself as a student, and you'll get access to loads and loads of knowledge that you can make use of and learn from without paying anything. So that is what I wanted to share with you today. I hope I have been able to do justice to the very short time that has given to me for this very, very vast topic. Any questions? Do we have questions? Yeah, any questions? Please ask from anyone. Yeah. Yes, sir. Professor Morris. Yes, sir. Sir, please don't, sir. I feel very uncomfortable at this time. Yes, sir.
Developing Android apps or iOS apps. Like that, if the students learn AI, agentic AI, and generative AI, if they are good in developing AI agents, will they be able to do well question is, do you foresee a future wherein in the war fields, the human soldiers are totally replaced by the
Drones.
AI weapons or something? They will exactly behave like human warriors, and the losses, human losses, can be avoided. These are the two questions. Thank you.
Yes, sir. Thank you, sir. I'll answer the first question. If you, I'll repeat the question because at the time he was not having his mic, so I assume some of you might not have heard about it. If you develop skill sets to create generative AI or you create agents, is that a good job opportunity? Absolutely yes. That is the hottest thing. Now, like I said earlier, I'll just go back to a slide. I skipped it because I wanted to save a little time there, but now Professor Monasundaram has asked it. I'll just cover that also quickly. So what are the steps? That answer is yes, right? So what are the steps that are creating the workflow or this is a very high level abstraction of areas which go of the work that gets into creating agents. Number one, data curation. I mentioned about it, how data is important. It has to be cooked to be able to be eaten. So data institution. Then distributed training. Like I said, very complex mathematical models. So parallelization is important to ensure that serially it cannot be done, right? I mean, you have to parallelize it. So distributed training, that is what we call as distributed computing, where multiple GPUs, graphics processing units, which are parallel computing agents, work in unison, right? But there is only one problem. The problem has to be taken and broken down into a large number of small threads, and all these threads have to be run in parallel. And at the end of the run, they have to be collated. So that is what I mean by distributed training. Customization of the model, right? You need to customize it to your company's needs, to your needs. Like, for example, if I take two different, Sun Pharmaceuticals is a pharmacy company and Novartis is another pharmaceutical company. The language used by Sun Pharmaceuticals is going to be different from Novartis. What works for Novartis will not work for Sun Pharmaceuticals, right? The assembly line that works for Suzuki Motors is not going to work for a Toyota because they use different assembly lines, etc., etc. So you need to customize it. Then inferencing, which is understanding the model. Retrieval augmented generation, where you connect it to the external database and get intelligence from that. Guardrails, which ensure that your answers are kept inside the topic areas of interest. No unparliamentary things comes into play. So these, each of these boxes can mushroom into 100 other boxes. If I blow out each box, there will be 100 other small boxes. So answer to Professor Monasundaram's question is that answer is yes. And it is, when I say you create agent, you don't just go and create agent. You work in one of these areas. Okay, and thousands and thousands of people work in huge companies, not thousands, tens of thousands, lakhs of people work in companies to ensure that all these things work seamlessly and the output is agent. Okay, and that is what we call as sir, a factory. What is a factory? A factory, raw material goes and finished goods come out. In a factory, data and electricity go in and intelligence comes out. That is what we mean by a factory. So answer your question is yes. The second question is, will AI be used in warfare, right? Absolutely yes. And the good thing about it, as you rightly pointed out, is that it is going to bring down loss of human lives because soldiers won't get shot. But then the big risk is that we are allowing a system to take decisions. Okay, the manual override can be, we don't know, it can be catastrophic. That is where the risks of AI that I talked about, how do I ensure control, is that one small miscalculation or an over-enthusiastic AI agent should not fire a wrong missile on somebody. So the good thing is loss of human lives will be minimalized or will be zero. But the risk involved there is the human element. With so many wars happening all around us, thank God, I hope it never happens. After Hiroshima and Nagasaki, no atomic bomb has ever been fired, right? I hope that will happen forever. So that is what is the risk involved there, sir.
We have to change our syllabus, right? Earlier mechanical engineering.
Yes, sir. Yes. The answer is yes. Yeah.
Very difficult, actually.
Yeah, I know that. AICTE norms and all, I know. Sir, yes, sir. Answer is yes. Autonomous vehicles, the good thing about autonomous vehicles is, what are the good things about autonomous vehicle? Is that they don't jump red light. When an autonomous vehicle has been trained to obey red light, it will obey red light. They don't sleep off. I mean, the accidents are caused when people jump red light, when people fall sleepy, when people talk on the phone and miss half a second. So, in an autonomous environment, those human errors and human mistakes are totally eliminated in the ideal world. I mean, I'm not talking about bugs, putting that aside, in ideal world. So, the answer is that. But can it be done in India? The most fundamental need for an autonomous vehicle to run in India is lanes. There are no lanes in India. The lane, when I say lanes, there are no lane markings in India. I'm sure, I mean, all of us, you go to any country, the road will be drawn with lanes and people stick to the lanes. I'm not talking about the discipline part. The government has to have the discipline of creating lanes. So, autonomous vehicle as a concept, how does an autonomous vehicle stay in line? Because there are two cameras or lidars that understand this white line and this white line and steer to be kept in a lane. There is no white line. What will it do, poor guy? Poor. So that is the problem in India. Okay. So citizen services, they use the term citizen services. What is citizen services? You call a helpline and you ask for a very complex answer, right? I mean, something like I told earlier. If I need to bring down my insurance payment by 30%, what is its impact on my overall coverage and which network hospitals will be eliminated? Things like that. Did I pay income tax last year? Things like that is called citizen services, and citizen services are getting automated in developed countries, right? For citizen services to get automated, the database has to be maintained properly. Otherwise, what is the point in having a great mathematical model where the data is not available, the right data cannot be fetched, right? So, answer is yes, sir. It has the potential to improve human life, provided the support systems are all in place.
Sir, I have one question, sir.
Yes, sir.
Thank you for the wonderful lecture, sir. The question is about how mechanical engineers can align with this large language models, as you mentioned. We need to more of learning this complex mathematical algorithm, or we need to learn how to use this model effectively.
Yes. You can do both. I mean, you can do either. It depends on your area of interest. The answer to your question, it is not necessarily you have to get into that. Leave it to the CSE students. I mean, they are learning that. Let them do it. But a CSE student will not be able to understand the basics of robotics, that how it is applied. So, I mean, obviously, I'm not restricting you to looking only at the applied side. You can go to the core side also. And it is your interest depending on it. But all I'm telling is, it is not that mechanical engineering students don't have a opening in AI. There is a lot that can be done on the applied side.
So one more question. You have telling about this omniverse thing. So will that be useful in academic for mechanical engineers?
So omniverse is a software environment. Like I'm sure you are aware of Autodesk software, Siemens, UGNX and all you might have heard of. Like that, it's a software environment for creating your digital twins, which does two things, look real and behave real. It's a software, that's it, yeah. From NVIDIA, I mean, because I'm from NVIDIA, I talk about omniverse.
Sir, good afternoon, sir.
Good afternoon.
Sir, your comments on artificial general intelligence and how NVIDIA is close to providing AGI solutions for the industries.
So, artificial general intelligence is an extension of this. We see, if I go back to my first slide, this is what is the evolution. Physical AI is the epitome today. But it will keep on, there is some, people also use the term called artificial super intelligence, which is beyond general AGI, ASI and all people use. Those are all concepts. Okay, and you take two different definitions from the way one book will define AGI is going to be different from how other book is going to define. These are all concepts, okay, English words. So, I mean, it will keep evolving. That's what I would say.
Sir, do you think Elon Musk will achieve it? I read the news yesterday. His next AI group will be artificial general intelligence.
Yes, artificial general intelligence is the next logical evolution. It will happen. where they become even more intelligent on what they are. We talked about reasoning, we talked about contextualization. Going beyond that is AGI, artificial general intelligence. Once again, please keep in mind that these are our concepts. There is nothing like a mathematical definition for AGI, right? It's not like a moment of inertia which can mathematically be defined. There is only one answer. What is a moment of inertia? Okay, what is a degree of freedom? There is only one answer. I mean, no, you ask anybody, degree of freedom means one only. AGI is English. It's a concept. Don't get too carried away by these fancy terms.
Thank you, sir.
Sir, adding to his question, as claimed by Elon Musk in this fifth version of that AGI, he is saying that it could replace all the PhDs in that any specific domain. It can perform better than a PhD. So that means that the forthcoming era should be more for generalists than a specialist. For a general specialization, for a general skills, generic skills, or than a specialized skills, because of this evolution of GPI, as told by Elon Musk.
So I honestly don't know what Elon Musk sold. I mean, it looks like he has told something which obviously I'm not aware. I have not read that. But all I'm telling is, see, your question is, will general skills be more employable or specific skills will be more employable? There is no 1-0 answer for this. Honestly, I don't want to mislead you by giving, hey, go for general skills or go for specific skills. It's very difficult for, I don't know the answer to that. It all depends on how, what your interest is and your skill set is. It's not that every one of us has been created same, right? We have interests and we have skill sets. So go behind what is of interest to you and go behind what you can develop your skill set on, right? That is what it is, and find something that works. I cannot make a statement that general skills are more important than specific skills or vice versa. It will never be that way. Yeah. There won't be a definitive answer to that. Okay. Thank you. Sorry, what is the second part, sir? Oh, yeah, no. There is something called a Turing test. I don't know whether you guys have, some of you, TURING, go and read about Turing test. So Turing test is a comparison between human generated output and then machine generated output, which is more accurate, which is faster, and in many areas, the Turing test has been favorable to machines. That is the fact today. And JEE and all has now been cracked by machines. JEE, IIT JEE, which is supposed to be the toughest, one of the toughest exam in the world, in the globe, machines are able to crack it.
Good afternoon, sir.
Yeah, hi, good afternoon. Yeah, go ahead, please.
Okay. So, two questions. The first one, as students who are passing out in the next few years, whether we like it or not, we are entering into the job market which is heavily influenced by AI. And as mechanical engineers, how do we prepare ourselves for that era of work?
Like I said earlier, that's what I was trying to tell you for the past 40 minutes or so, is that identify your area of passion and develop your skill. You have to develop your skill set. Don't restrict to what is taught in the university, because university has got its own restrictions like AICTE norms, and it is not easy for a university to change the syllabus in one night. Okay, so university gives you the mathematical foundation is what your university, your institution, our university can give us, right? We need to ensure that the mathematical foundation is used to learn allied fields, identify your area of interest, identify your skill set very importantly, and go behind that. That is how I would suggest that you should prepare yourselves.
Yeah. And so my second question is sort of a follow-up question to a question which was asked earlier. So I think one of the professors in front asked you about the next era of warfare where soldiers will be controlled by AI. So following up on that, lethal autonomous weapon systems are being debated by governments around the world and even in the United Nations. So these machines can independently identify and choose to whether spare a target or to eliminate it. So this raises a lot of ethics concerns, as you mentioned in your talk earlier. So obviously there are companies working on systems such as these right now, and how do they decide who to spare, who to target?
Yeah. So that is where this concept of guardrails come into play. If you remember this slide which I showed you earlier, the last box is called guardrails. So what are guardrails? Guardrails are set of very strict rules and regulations that do two things. Number one is to ensure that your responses, the outcomes, are restricted to your topic of interest. Okay. Number two is that it doesn't breach any of the ethical codes of conduct. Right? That is what it is. Restrict yourself to topic of interest and not breaching ethical standards as defined by human beings. Now ethics itself is an ambiguous term, right? I mean, how do I define ethics? I mean, see, I'll just tell. So, one country's patriot is another country's, the neighboring country's terrorist, right? I mean, I don't want to use names here, but whoever we think as patriots and martyrs, our neighboring country will define as a terrorist and vice versa. So all I'm trying to say here is that it's a very complex thing, right? I mean, it's extraordinarily complex, and I mean, obviously I'm not a warfare expert. I don't have an answer to your question, but what you said is a viable problem. Okay, so who can solve the problem? You tell me now. Who can solve a problem? That problem?
The people who will build it in the near future.
Right? No. People like you.
Exactly. Yeah.
Engineers only can solve the problem. So good opportunity for you. That's it.
And sir, the ethics concerns don't limit itself to warfare only. It can even be, as you said, autonomous vehicles.
Yes.
So
everything. Yeah.
Who is responsible for the ethical decisions made by AI systems, sir?
So that is what it is. So what is AI? How does PhD Tech frame its syllabus? Through AICTE norms, right, sir? So there is a governing council body called AICTE. Now governing councils and governing bodies for AI are coming already, right? Every medical council ensures IMS works properly, the syllabus is done properly, the right things are taught. There's a judiciary council that like that, AI will have its own council, and that's a huge opportunity, defining that. So it has opened up new avenues where people will be working, which has not been done so far. That is what you should think about. Don't worry about who will do that. I mean, who cares? I mean, at your age, you should not care about it. You should look at how does this create an opportunity for me, and how do I, segue myself into that opportunity and ensure that my passion, my skill set is refined, is honed to solve a problem which is created by AI. Okay, you cannot solve AI problem. You cannot solve the problem created by AI. So don't stop worrying about it. Okay.
Thank you, sir.
Sure.
Good afternoon, sir. Sir, as a mechanical engineer, if you want to, feed data into this digital twin, let's say how the flows in a pipe goes, all that. So do you necessarily need to know coding, or like what other alternatives are there for me to, train such a model, or, help people who create digital twins with the knowledge of mechanical engineering?
Learn software, right? I mean, I'm sure you would have learned drafting, 3D modeling and all, right?
Yeah.
I mean, do you really worry how, like you have to create the 3D model of assembly of a machine? Do you really worry about this? The Python and the C++ programming went into creating UGNX or Siemens? No. You learned the package, right? Called UGNX or Autodesk or whatever it is. Like that, learn the software. If you don't want to go into coding, learn software. I have never done coding in my life, I'm telling you.
Yeah. So, do you know any software like wherein I can train?
Lots of them. Omniverse is one. I mentioned about Omniverse, which is used for virtual twins. But I mean, it's not one or two. I mean, it could be like hundreds of software. And I mean, robotics, there are so many software that are there for robotics, if you're interested in robotics, right? So I mean, like I said, I cannot tell you that these three software, because then I'll be misleading you and all three of you will go behind, 200 of you will go behind those three software. So there are like many of them, hundreds of them. Yeah.
Thanks.
Thank you, sir, for your thought-provoking and deeply insightful lecture. Your perspectives Your perspectives on building advanced AI agents and generative AI will no doubt inspire both researchers and students here today. We are especially grateful for the way you addressed and answered the questions of many, making the session even more engaging and valuable.
As a mark of respect and gesture of a warm gratitude, may I now request Dr. B. Giriraj, Principal, PSG Polytechnic College, to present a shawl to our chief guest. Thank you, sir. Now, as a token of appreciation, may I invite Ms. S. Vidya, Vice President of PSG Tech Alumni Association, to present a memento to our chief guest.
Thank you, sir. This gesture of gratitude reflects the deep appreciation we hold for our chief guest's time and contribution. Every successful event is made possible by collaboration and goodwill. Today's program too is a result. Today's program too is the result of the collective efforts of many.
To extend our gratitude to all who made this possible, I now invite Dr. K. Kannan, Professor and Head of Department of Mechanical Engineering, PSG College of Technology, to deliver the vote of thanks.
Good afternoon. Good afternoon to everyone present. On behalf of PhD Tech Alumni Association and Department of Mechanical Engineering, it is my privilege and pleasure to propose the vote of thanks on this special occasion. First and foremost, I extend my heartfelt gratitude to our esteemed chief guest, Mr. Sundar Ramalingam, for gracing this event with his presence and for sharing his valuable thoughts that have truly inspired us. I place on record our sincere thanks to Dr. K.Prakashan, Principal, PSG College of Technology, for his constant encouragement and support, which has been the driving force behind all our endeavors. I extend my gratitude to Dr. B. Giriraj, Principal, PSG Polytechnic College, for his guidance and valuable presence on this occasion. Our special thanks to Dr. R. Rudramurthy, Director, PSG CARE, for his visionary leadership and continuous motivation that enrich all our initiatives. We are deeply thankful to Mr. Krishna Kumar, President, PSG Tech Alumni Association, Ms. S. Vidya, Vice President, PSG Tech Alumni Association, and Dr. M. Arasu, General Secretary, PSG Tech Alumni Association, for their unwavering support and commitment to strengthen alumni network. A special word of appreciation goes to Dr. Prasad Raju, former scientist, DST, Government of India, for instituting the PR Endowment lecture, which adds immense value and meaning to today's gathering. We are equally grateful to our alumni members, deans, head of departments, faculty members, staff members, and students for their active participation and enthusiastic involvement, which has made this event a memorable one. Finally, my heartfelt thanks to the organizing team, volunteers, and everyone who worked behind the scenes to ensure the smooth conduct of today's program. With that, I once again thank you all for being with us today and making this event a grand success. Thank you.
Thank you, sir. Now, to conclude this occasion, may I request everyone to rise for the national anthem.
शुभ नामे जागे तब शुभ आशीष